Okay, so welcome to section, actually 8.1 at this point, which is complex numbers. Okay, so let's recall. So the domain of the square root function, the domain of f of x, oh boy, f of x being equal to the square root of x is between 0 and infinity. That is, I can't take the square root of a negative number. Okay, so i.e., that is id est. We cannot take the square root of a negative number. The square root of a negative number, and arrive at a real number. Okay, so there is no real number that is a square root of a negative. Okay, so definition. In definition, okay, I can say that word. Definition. So the imaginary unit, that's what I'm defining. The imaginary unit denoted by I, so denoted by just the letter I, is given by I is equal to the square root of -1. So alternately, I squared is -1. Okay, so let's note. So for all real numbers, k, this implies that the square root of -k can be written as the square root of k times -1, which we can then write as the square root of k times the square root of -1, which is the square root of k times I. Okay, so now we have an imaginary unit. Now these are not real numbers, okay? So let's consider the following properties of I. So consider I is just I. I squared we know to be -1. So I cubed would be -1 times I, right? So that's just going to be -1, or actually let me be explicit. Well, I'll say -I and I'll show you why here. And that's because I cubed is I squared times I. And I squared is -1 and I is just I. Whereas I to the fourth is going to be 1, and why is that? Well, that's because I to the fourth can be thought of as I squared times I squared, using properties of exponents. So a -1 times a -1 is a +1. Okay, so continuing on then, I to the fifth is just 1 I to the fourth times I, so it's just I. So that's because I to the fifth is I to the fourth times I, and we know I to the fourth is just 1. I to the 6th is I to the 5th times I, so I squared, right? Which we know to be -1. So let me do that. That's because I to the 6th is I to the 5th times I, which is I squared. Okay. I to the 7th will be -1 times I, so -I. And I to the 8th will be -I times I, which is +1. So this is interesting. If I went I to the 9th, I would have I to the 8th, which is 1 times I, which is I. I to the 10th would be I to the 9th, which is I, times I, which is I squared, or -1. Do you see a pattern here? I to the 11th will be -I, and I to the 12th will be +1. So what's happening is we get a cycle of 4. So, theorem. So, I to the 4k is defined to be 1 for all integers. Okay. Okay. So, let's see this in example. So, example, simplify the following. So, number 1, let's say I have I to the, 99. Okay, so I to the 99. My goal is to rewrite 99 as a power of 4. So 99. 4 does not go into 99. 4 goes into 100. So therefore, 4 must go into 96. So I'm going to write 99 as 96 plus 3. Okay. So what does that give me? That gives me I to the 4 goes into 9 how many times? 4 goes into 9 twice. Okay, with 1 left over, and 4 goes into 16 4 times. So this is 2 times 4. Actually, I wanted to write the 4 in hot pink. Let me reverse the color scheme there. So it's 2 times... Wait, what was I doing? Wow, I don't even remember. So 24 times 4 gives me 96 plus 3. So now I can break this up using properties of I. So I can, or exponents rather. I can write this as I to the 24 times 4 times I cubed. Because that's how we add the exponents if the base is the same. Well, what's interesting about any integer multiple of 4 in the exponent is it's the same as 1. So this is really just 1 times I cubed, as long as it's a multiple of 4. So I cubed we know is -I, according to the first 4 guys. Okay, let's do another one. Number 2, what shall we do for number 2? Let's do I to the 133. How about that? Okay, so we have I to the 133, not 33, 133. Let's make it a bit more difficult. So 133. Okay, so I'm looking for a multiple of 4 there. Well, let's see, 4 goes into 12, so that's 120. And if I add 8, that's 128. So it should go into 132, right? Okay, so I'm going to write this as I to the 132 plus 1. Okay, so now let's see. How many times does 4 go into 132? Well, 4 goes into 100, 25 times. 4 quarters makes $1. And then 4 goes into 32 8 times, so 25 and 8 should be 2 shy of 35, or 33 times 4. Plus 1. So I'm now going to write this as I to the 33 times 4 times just I to the first power. So I know that any multiple of 4 in the exponent makes that value of I just 1. So this is 1 times I to the first, otherwise known as I. Okay, let's do another one. Third time's a charm. Okay, so what should we do? Let's do I to the 423. Okay. What color should I use here? Let's use orange. So I to the 423. Well, it should be clear that 4 goes into 400, and 4 goes into 20. So I believe 4 goes into 420. So I to the 420 plus 3, and actually I should have done that 420 in purple. So 420. Okay, so now let's do the division. So we have I, so 4 goes into 4 once and into 25 times. So is this 100? It should be, wait. 4 goes into 4 once and into 2005. So 105, there we go. I'm like, something's wrong there. 105 times 4 plus 3. And why do I keep on not doing that in purple? Okay, this 105 should be in purple. Okay, so now let's break this up into I to the 105 times 4 times I cubed. Okay, well, anything that has a power of 4 in the exponent of I can be simplified to 1 times I cubed. And once again, I cubed is negative I. Okay, so I know that's kind of silly, but hopefully that makes sense. Okay, so now let's do some examples with numbers. So for example, express the following in terms of I. Okay, so number 1, let's say I have the square root of negative 36. Okay, so the square root of negative 36. I'm going to write this as the square root of 36 times, let me color code this. Yellow, should I do yellow for this one? Let's do purple again, negative 1. So this will be the square root of 36 times the square root of negative 1. Well, the square root of 36 is 6. And the square root of negative 1 by definition is I. So it's 6I. Okay, so number 2. Let's do the square root of negative 81. Okay, so we have the square root of negative 81. Make that better. So this will be the square root of 81 times negative 1, getting ahead of myself, which I can then break up into the square root of 81 times the square root of negative 1. So this is going to be 9. Square root of 81 is 9, and the square root of negative 1 by definition is I. Number 3. Okay, what shall we do? Let's do the square root of negative 25. How about that? Okay, so we have the square root of negative 25. What's that, kitty? So this will be the square root of 25 times negative 1. Or the square root of 25 times the square root of negative 1. Otherwise known as Square root of 25 is 5, and the square root of -1 is I. Okay, so let me define what a complex number is, because that's what this section is. So definition. So complex numbers that's what we're defining, denoted by, or denoted as a field by blackboard bold C, much like we have blackboard bold R for real numbers, are of the form Z is equal to A plus B times I, where A is equal to the real part and B, without the I, is the imaginary part. So these are the coefficients of each part. So we have one real part and one imaginary part. Okay, so let's note. So Z equal to A plus BI is standard form. So is the standard form. Standard form for all numbers Z in the complex numbers. Okay, so for example, so let's express the following complex numbers in standard form. So express the following complex numbers. In standard form. Okay, so number 1, let's say we have 3 plus the square root of -100. Okay, so we have 3 plus, I'll just keep this blue for a moment, the square root of -100. So that's 3 plus the square root of 100 times -1. Which is going to be 3 plus the square root of 100 times the square root of -1. So that's going to be 3 plus 10 times I. And there we are in standard form. Should I leave a space in between, or hopefully you guys are able to see that? It's not too crunched together. So number 2, what do we have? Let's do 5 minus the square root of -9 all over 4. So we have 5 minus the square root of -9 all over 4. So this will be 5 minus the square root of 9 times a -1. All over 4. So that'll be 5 minus the square root of 9 times the square root of -1 all over 4. Which will be 5 minus 3 times I. And if I want this in standard form, the 4, that's the common denominator to both, has to be separated into 2 distinct terms. Okay, so there we are. Let's do number 3. 3 times the charm, 7 7, not z. 7 minus the square root of negative 25. Okay, so I have 7 minus the square root of negative 25 will be 7 minus the square root of 25 times a negative 1, which is 7 minus the square root of 25 times the square root of negative 1. Okay, so what does that give us? Actually, maybe I could put this beneath it. Oops, that's not what I wanted to do. Let's just put this beneath. We don't need the extra vertical space. So this becomes 7 minus 5 times I in standard form. Okay, I think I'm going to leave the next subtopic for the next video. I'll see you then.